6524. As airspeed increases in level flight, total drag of an aircraft becomes greater than the total drag produced at the maximum lift/drag speed because of the A. Increase in induced drag. B. Decrease in induced drag. C. Increase in parasite drag. The correct answer is C. As airspeed increases in level flight, the total drag of an aircraft becomes greater than the total drag produced at the maximum lift/drag speed because of the increase in parasite drag. Parasite drag is a form of drag that is caused by factors other than the production of lift. It includes components such as form drag, skin friction drags, and interference drag. When an aircraft flies at higher speeds, the airflow encounters more resistance due to the shape of the aircraft, surface roughness, and interactions between different components. This leads to an increase in parasite drag. Form drag is caused by the shape of the aircraft. At higher speeds, the air encounters a larger frontal area, resulting in increased form drag. The pressure differences and turbulence created by the shape of the aircraft contribute to this drag component. Skin friction drag is caused by the friction between the aircraft's surface and the surrounding air. As airspeed increases, the relative velocity between the air and the aircraft's surface also increases, resulting in greater skin friction drag. Interference drag occurs when the airflow between different components of the aircraft disrupts the smooth flow of air. At higher speeds, the interactions between the wings, fuselage, and other parts of the aircraft become more significant, leading to increased interference drag. The increase in parasite drag as airspeed increases contributes to a higher total drag. This is why the total drag of an aircraft becomes greater than the total drag produced at the maximum lift/drag speed. In summary, the increase in total drag at higher airspeeds in level flight is primarily due to the increase in parasite drag, which includes components such as form drag, skin friction drags, and interference drag. 6525. As airspeed decreases in level flight, total drag of an aircraft becomes greater than the total drag produced at the maximum lift/drag speed because of the A. Decrease in induced drag. B. Increase in induced drag. C. Increase in parasite drag. The correct answer is B. As airspeed decreases in level flight, the total drag of an aircraft becomes greater than the total drag produced at the maximum lift/drag speed because of the increase in induced drag. Induced drag is a type of drag that is generated as a result of the production of lift by the wings. It is directly related to the angle of attack and the lift being generated. When an aircraft generates lift, there is a pressure difference between the upper and lower surfaces of the wings, creating wingtip vortices. At lower airspeeds, the airflow over the wings becomes less streamlined, resulting in stronger and larger wingtip vortices. These vortices cause a downward deflection of the airflow, leading to an increase in induced drag. The increase in induced drag as airspeed decreases is primarily due to the higher angle of attack required to maintain lift. As the airspeed decreases, the wings need to generate more lift to support the weight of the aircraft, resulting in a higher angle of attack. This higher angle of attack leads to increased induced drag. Induced drag is inversely proportional to the square of the airspeed. As the airspeed decreases, the induced drag increases at a greater rate, causing the total drag to become greater than the total drag produced at the maximum lift/drag speed. 6526. The resistance, or skin friction, due to the viscosity of the air as it passes along the surface of a wing is called A. Form drag. B. Profile drag. C. Parasite drag. The correct answer is B. The resistance, or skin friction, due to the viscosity of the air as it passes along the surface of a wing is called profile drag. Profile drag is specifically related to the frictional resistance encountered by an aircraft's wing as it moves through the air. When air flows over the wing's surface, it adheres to the surface due to viscosity. This creates a layer of air molecules that move with the wing, resulting in friction and drag. The magnitude of profile drag is influenced by factors such as the smoothness of the wing's surface, the length of the wing, and the speed of the airflow. A rougher wing surface or a longer wing will increase profile drag, while a smoother surface or a shorter wing will reduce it. In conclusion, the resistance due to the viscosity of the air along the surface of a wing is known as profile drag. It is specifically related to the skin friction and is influenced by factors such as wing surface smoothness, length, and airflow speed. 6527. Which relationship is correct when comparing drag and airspeed? A. Induced drag increases as the square of the airspeed. B. Induced drag varies inversely as the square of the airspeed. C. Profile drag varies inversely as the square of the airspeed. The correct answer is B. The correct relationship when comparing drag and airspeed is that induced drag varies inversely as the square of the airspeed. Induced drag is the component of drag that is generated as a result of the production of lift. It is caused by the creation of wingtip vortices and the associated downwash. As the airspeed increases, the strength of the wingtip vortices decreases, leading to a reduction in induced drag. Conversely, as the airspeed decreases, the wingtip vortices become stronger, resulting in an increase in induced drag. The inverse relationship between induced drag and airspeed can be explained by the lift equation. Lift is directly proportional to the airspeed squared. L is proportional to v(2), and induced drag is directly related to the lift generated by the wing. Therefore, induced drag varies inversely with the square of the airspeed. It's important to note that this relationship holds true only for induced drag. Other components of drag, such as Parasite drag, which includes form drag and profile drag, do not necessarily follow the same relationship with airspeed. 6517. The force which imparts a change in the velocity of a mass is called A. Work, B. Power, C. Thrust. The correct answer is C. Thrust is the force that imparts a change in the velocity of a mass. It is the force produced by engines or propulsion systems that propels an object forward, overcoming resistance such as drag or air resistance. Thrust is commonly associated with propulsion in the context of aircraft, rockets, and other vehicles. When an engine generates thrust, it expels a mass of fluid or exhaust gases at high velocity in the opposite direction. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. As the exhaust gases are expelled backward, an equal and opposite force, known as thrust, is generated in the forward direction, propelling the vehicle or object. Thrust is directly related to the mass flow rate and the velocity of the expelled gases or fluid. By increasing either the mass flow rate or the velocity, the magnitude of thrust can be increased, resulting in a greater change in the velocity of the object. In contrast, work is the transfer of energy that occurs when a force acts upon an object and causes it to move. Power, on the other hand, is the rate at which work is done or energy is transferred. While work and power are related to the concept of force and motion, they are not specifically associated with the force that imparts a change in velocity, which is thrust in this case.